Okay, so today we're going to look at a new way to look at a parabola in the equation. This is a lot less about formulas than you're used to. So you need to be taking notes, and if you need to pause and back up and listen to it again, that's why we're doing this on video. And it's going to feel a little bit different than you're used to because it's not about formulas. But you can do this. So as we look at this graph right here, okay, so if we look here, we have a nice parabola. Okay, and the only thing we really know are its x-intercepts and its y-intercept. Okay, and if we want to try and look at what equation this could possibly be. So when I'm looking at this, if I know the roots are -5 and 1, I'm going to try and make an equation from this. And in a sense, we're working backwards from what we used to do. So if -5 and 1 are the roots, then that means the factored form is this. Okay, I'm going to do something over here. Let's say I had this equation, okay, and I said, oh, find the x-intercepts. You would factor it, and then you would get the roots being -5 and 1. What we're doing is, we're used to going this way, right? This is what we're used to doing. Now, we're going to work up. We're going to go the other way. So, here we go, and then we'll FOIL this out. X squared, right, minus x plus 5x, and then minus 5. Okay, so as we look at this, notice a few things. Our roots, -5 and 1, are right here. And here, our y-intercept is -5, and look, that's what our y-intercept is. Okay, one thing that's interesting, or one thing to notice on here, is we don't know our vertex right now. We know how to figure it out, but we don't know it. Now, we know a parabola is symmetrical. So if we look at these roots, they're 6 apart, right? So from -5 to 1 is 6. So halfway is if we went 3, okay, which happens to be right here at -2, right? So what we're saying is this distance is 3, and this distance is 3, okay? 3, 3, right? From 5 to -2, -2 to 1. Okay, so this line right here cuts the parabola right in half. Okay, this is called, and this is an important word, the axis of symmetry. Okay, the axis of symmetry. And its equation is x equals, in this case, -2. Okay, that -2 comes from here. Vertical line, x equals, you know that. So what that tells us, though, is that our vertex is, so our vertex here is at x equals -2. So now, to find the y-coordinate, do what we did before. So we plug it in to our equation, and we're going to get -17. So this point right here, our vertex, is -2, -17. Okay? So this is one equation. So this equation right here is the equation of this parabola, okay, that has these roots and this y-intercept. Okay, so now we're going to look at this graph. So we again have the same red parabola here, right here, that has roots at -5 and 1. It has a y-intercept of -5. We know that's the equation. But now I want to look at this green parabola. So this green parabola still has the same roots, but the y-intercept is different. So the roots are still -5 and 1. So in factored form, we know we're going to have this situation going on. So if we multiply this out, we've already done this. Here's what we get. What we have now, this problem we have, is that this is -5, but we want it to be -10. So how could we turn -5 into -10? What we're going to do is we're going to multiply this entire equation by 2. We can distribute, so we'll get 2x squared plus 8x minus 10. Okay, now it's really clear, hey, the y-intercept is right. And if you want to look, right, if we look at this whole sequence of events backwards, we undistribute the 2, we factor, and we get our roots being -5 and 1. Okay, so if you have a parabola whose roots you know, right, you can always write a base factored version, and then you can adjust the factored version so that you get the y-intercept that you would like. Okay, here's another problem we can think about. Write the equation of a parabola with roots -5 and 1, but with the y-intercept of 10. So that's going to be up here, the y-intercept of 10. So I'm going to keep my scale the same. So here's 10. Okay? Okay, so we know this red one we know is x squared plus 4x minus 5, and that comes from this. Okay, so we want to start in the same place. Our roots are -5 and 1, so we'll put the factored form. And then we're going to multiply it out. And what we want to do is we want to change this to be 10. So what we're going to have to multiply by is -2. So we multiply, so we get -2x squared minus 8x plus 10. And that makes a lot of sense if you think about it. Okay, because in order to make that happen, right, we have to go down to have the same x-intercepts, and this being the y-intercept, and look, our a is negative. Okay, now we talked about the axis of symmetry here being 2, right, and x equals -2 is our axis of symmetry. Again, 3 units on each side. So if we wanted to find the vertex of this parabola with y-intercept 10, all we're going to do is we're going to put in -2 for x, right? And when we do that, our result is 18. So our vertex is -2, 18. So this is our vertex. Okay, so up here, we know this is -2, 18. Okay, here's another example, another problem to do. So find the equation of a parabola with the roots -4 and 2. I always like to use a graph so we have a picture of this. So here's -4 and here's 2. Okay, -4 and 2. On this one, they're not telling us what we want, what the y-intercept is, because there's a lot of different equations that have these as roots. We just need to find one. So if the roots are -4 and 2, one we can factor, right? And then we can multiply it out. So we get x squared plus 4x minus 2x, right, if we do all of this. We do all this, so plus 4x, so we get plus 2x minus 8. Okay, this is a great equation. It has -4 and 2 as the roots. So now if we go to -8, we'll go -2, -4, -6, -8 is our y-intercept. Okay, so we know about what it's going to look like, but let's find the vertex now. Okay, so the y-intercept is easy. It's c, y-intercept equals -8. Okay, the vertex, so let's find our axis of symmetry. So what we need to do is say, how far is this? This is 6. So again, we're going to go 3 on either side, which will put us right at -1. Okay, so our axis of symmetry is -1, which means that's the x-coordinate of our vertex. So we're going to plug in -1 into this situation. When you do those calculations, you get -9. Okay, so that means our vertex is at, -1, -9. No formula. Okay, so we can kind of start drawing this in, and then on this side we need a symmetric point. Exact same way we did it before. We're just gonna same Okay, so again, same y as the y-intercept. And then our x, we were 1 here, so we're 1 here. And now we can connect in a nice smooth curve. Okay, so our symmetric point will be -2, -8. Right? And there's our parabola. Now, there are many other equations you could have written. Okay? So this is our equation. We could have multiplied that equation by anything and still gotten -4 and 2 as our if we had taken our equation and multiply it all by 3x squared plus 6x minus 24. So we took this equation and multiplied it by 3, right? The difference is that our y-intercept is now -24, which is way down here somewhere. It's still going to go through -4 and 2, but it's going to be way down here where it crosses, we didn't have good, but if it crosses right here at -24. The vertex still has a -1 here, okay, but the y-coordinate is going to be dramatically different, right? So the y-coordinate is going to be -27. Okay, so this is now going to be -1, -27. Okay? Okay. There's one other just quick thing I want to talk about, and that is called a double root. Okay? Double roots are when the graph, and I don't have a pretty graph for this, I'll just draw one, is when the vertex is, let's make it be, say, -1. So if we have a double root in this case at -1, or x equals -1, it means our parabola is going to look like that our vertex and our x-intercepts are the same. So what this means is that we have two roots at -1. So when we do the factored version, it's going to look like that. We multiply it out. Okay, our y-intercept is 1 in this case if we're not going to multiply it by anything. Okay, and then we can get a symmetric point. So we went over 1, up 1. So we have to go over 1, up 1. So our symmetric point is going to be at -2, 1. And that's all we can do because our y-intercept and our x-intercepts are the same. Okay? If I wanted to make this whole thing, but now I wanted the y-intercept to be 4. So I'm changing it. Then I need to just multiply this equation by 4. 4x squared plus 8x plus 4. Okay? So this equation does have a double root at 1. Or at -1, sorry. Double root at -1.